Thank you. So, 1/3 of food produced for human consumption is wasted globally each year. And I think the first time I heard that, I could just not believe it because it's an astonishing figure. I think, first of all, from a humanitarian perspective, this is difficult to justify given that people still suffer from hunger and malnutrition every day. I would myself have a hard time explaining and justifying this to my kids, really, if I would have to. But also from an environmental perspective, this is just mind-blowing because it is estimated that roughly 8 to 10% of all the global greenhouse gas emissions is associated with producing food that we don't even consume in the end. So if you consider this, you could actually lower greenhouse gas emissions considerably if it would just be a bit more efficient and waste less food. My name is Ruben. I work at Albert Heijn. This is Anant. He's my colleague. And for those of you who might not be from here or are from abroad, Albert Heijn is the leading grocery retailer in the Netherlands. We have online and offline presence. We are also present in Belgium. To give you a bit of an idea, we have 1,200 stores, and yeah, like I mentioned, it's both online and offline. Today's talk will mostly be about what happens in our brick and mortar stores. So at Albert Heijn ourselves, we are pretty ambitious when it comes to reducing food waste ourselves. Our ambition is actually to reduce 50% of the food waste in 2030 if we compare it to 2016. This is in line with the ambition that the United Nations set in 2016, and this is the ambition that we as Albert Heijn embraced and trying to achieve by then. Yeah, so and in today's talk, what we like to explain to you is how we use both AI and, let's say, business knowledge and domain knowledge as complementary forces, really. And we like to explain to you what our journey has been in adopting AI as a complementary method to all the very smart people that work in our company. And this talk is really about, let's say, how we leverage that for minimizing food waste, while at the same time making sure that product availability is maximized. Because of course, I'm not gonna dance around it. We are a for-profit company. So in the end, if you as a customer visits our stores, we want to make sure that there's everything for you, that everything is available, but that only at the end of the day, we don't have to throw anything away. That is kind of what it boils down to. And how does that work? It actually all starts with good forecast. It all starts with good forecast. Because these forecasts we use for all kinds of decisions around, okay, how many should we ship to each store? How many cucumbers should we source from our suppliers? All these kind of questions we can address if we have accurate forecasts. And what is our take on it? Well, we use machine learning for it, and we make forecasts for every store and for every article in the store, and then we do it 50 days ahead. So for every of these combinations, we make forecasts every night. Is there anyone good in arithmetic who has an idea of how many combinations these are? Some people know. It's more than 1 billion. It's 1,020 million forecasts. We make them every night, just to make sure that we have these decisions around replenishment and the supply chain, that we have them right. Yeah, but how do you actually make 1 billion forecasts every night? How do you go about, and how does that work? Well, there's many, I think, different ways about running such a large-scale machine learning operation. We have converged to the setup where we use actually many machine learning models in production. So what does that mean? We now have 2,500 models in production. It is a lot now I think of it. And we have a model for every coherent group of items. So for example, for milk, we have a model. For cucumbers, we have a model, etc. Yeah? Of course, you could think also of thinking of running this in a single model, and well, you can do it. We tried, didn't work for us. Another very important aspect of this is that we are interested in demand and not sales. And this is essential. Why? Well, if some product is not available for some time, you observe sales and not how much you could have sold if everything would have been available. And that is what we're interested in. We're interested in what is the demand, how much can you sell if something is available all day. So before we actually start doing machine learning, we try to address this question based on sales and stock out information, what is the actual demand that is in the market, because that is what we're after. And then we have a strong focus on data-centric machine learning because we cannot nurture every single model in isolation because there are 2,500. So what our take is that we make sure that whatever goes into the model, the features is of high quality. And then, and that is, let's say, how we can scale and work with 2,500 models. And then lastly, but not unimportantly, we have a custom experimentation platform. If you do machine learning on such a large scale, it is impossible for data scientists to run experiments effectively on their own laptop. So we have built something that makes it possible to run experiments in an effective way and in a, let's say, time-effective way and also in a scalable way. For those of you who are interested in technology, this is what we, let me step to the front, this is basically what our technology stack looks like. A lot of data stuff happens on Databricks. I think Databricks is very happy with us. It's pretty heavy-duty stuff. For machine learning, maybe it's interesting, we use LightGBM. LightGBM has proven time and time again that for these kind of time series forecasting problems, it has superior performance. If you look at all kinds of forecasting competitions in recent years, LightGBM is always at least part of the winning solution. And it's also easy to implement, actually. Airflow is at the central heart of everything because it orchestrates everything. And then for Grafana, we use monitoring because if you make so many forecasts, you have to have some sort of automated way to monitor actually all the forecasts that you're pushing out. We built it completely custom because we consider this a core capability. And that's why we developed it ourselves. And that's the case for many data science projects that we do. I don't think that you can even buy this off the shelf, but it was also, let's say, never our plan. So how did we get here? I think it might be interesting to some of you. How do you go from 0 models to 2,500? Yeah, I mean, like, it doesn't happen overnight. And how do you make this how do you make that a success? Well, it's certainly a marathon and not a sprint. It took well over 3 years to actually build this and go live with everything. It's a long time. The key ingredients for success, however, was, I think the most important one is to start small. This emoticon got screwed up, but it is a bowl of rice. It's unrecognizable. But it is to illustrate that this was actually, we started with forecasting rice and peanut butter and those kind of things. Dutch people love peanut butter, but the good thing is they eat it all year throughout. They don't eat more during Christmas or less when the sun shines, so it's easy to forecast. That's how we started, to kind of like prove that we can do it and to get into the groove, so to speak. And then I think over time, we added more and more products to let's say, to the scope. And this went category by category. And then there were all kinds of growing pains. It turned out we could not forecast ice creams well. Well, we improved the model. At some time, the infrastructure was no longer able to consume all the forecasts, so we had to work there. So it was an organic process. At the same time, we always had focus on value, because it's, for some products, not at all, it's for some products more important to have an accurate forecast than others. For fresh products, you need to be spot on. For other products with the long shelf life, the consequence of a poor forecast is of less, is smaller, so to speak. And then, of course, it is a long-term investment. So if you start a project like this and expect all kinds of results the next week, that's not going to work. So you have to know that, okay, we're going to invest a lot of time and money, but in the end, if you do the mathematics, you know in the long term this is going to pay off. And that has always been our take on this. This last one goes without saying, I think, and always holds. We had bi-weekly meetings with all kinds of users of our forecast to make sure that we were doing the right things and focusing on the right issues. So you might think now, because you use AI, all forecasts are spot on, right? Because if you read the newspaper, then it seems everything is possible. Well, this is certainly not the case. Actually, many of the forecasts we make are of poor quality. Most are pretty good, I would say, but there's definitely forecasts that are poor for all kinds of reasons. Our business likes to introduce all kinds of new items. We open up new stores. We have data quality issues. There's many reasons why your machine learning performs poorly in the circumstances at hand. And you know, when you think you've seen it all, then this happened. Oh, then this happens. Locals will know what it is. It is some sort of food innovation. Someone decided to mix up Dutch pastries with the French croissant, and then you end up with this. Then on TikTok, people were crazy about it, and demand spiked out of nowhere. You can never see that coming. So the key point is you cannot rely on AI or ML for these kind of things. And I think that's also definitely the case, for example, for Christmas. Christmas is super challenging for machine learning. Why is it? There's all kinds of Christmas-specific assortment that you don't see throughout the year. You know, it's only available for this few weeks around Christmas, and then every year they also introduce all kinds of new items. So actually you have small data, and machine learning and AI is extremely data hungry. So Christmas is only once a year. It's on a different day of the week every year. So actually you have very little data to work with, and this is where your machine learning is going to suffer a lot. While in fact, the stakes are high, because for the business, it's the most important time of the year. We make a lot of money during Christmas. I'm not going to lie about it, but it's also from marketing perspective super important to have Christmas right. We can welcome new customers to our stores, all this kind of thing. It is, from a business perspective, most important time of year, while for machine learning, it's terrible. So last Christmas, Christmas 2024, 3% of all our items were actually adjusted manually. So someone had to intervene. And the question is, of course, if you make so many forecasts, which of these forecasts need an intervention? If we push out 1 billion forecasts, how do you even know where to look at? And even if you have identified which forecasts are likely poor, how do you adjust these forecasts so that they are of better quality? And these are, I think, very interesting but challenging questions. And also, in terms of tracking and monitoring, how do you, when the volumes are so large, how do you effectively make sure that the interventions are right, the forecasts are right, and that during Christmas we have high availability and low waste, all these kind of things? Well, for this, it is essential to have downstream, to have effective tools for the people in the supply chain that monitor this and make the right decisions. And Anant knows all about this, so Anant, the floor is yours.
Thank you. So, let's take a look at how all of this works. Just the way Ruben handed me the, let's say, the floor, he hands me the forecast. And while most of these forecasts end up at our distribution centers to be converted into orders that go to a store, there are, of course, some of these forecasts that have to be looked at manually. And this is where the human experience, the human knowledge, expertise comes into play. So let's take the example of the snack item that just went viral. And let's say I'm a business user. I work in the replenishment department of Albert Heijn. And my task is to make sure that the right forecasts or the most accurate forecasts end up at our distribution centers. In this case, I was very lucky that I go to my office one day and I hear from our commerce department that this item has gone viral and we have to do something about it. But a lot of times, this is not the case also. It is really good to have some sort of alerting in place, which tells us that some items or some items need to be looked at or have to be intervened. And these alerts, of course, can be as simple as looking at the past day and seeing if the forecast and sales have a big difference between them. Then that's a good candidate, for example, for intervening. coming back to this example, so now I'm the business user. I get the news that this item has gone viral. There is demand out of nowhere for this. So what do? I know that we have to send more to the stores because we know customers are going to buy it, right? So I need to go adjust my forecast. And in order to do that, it would really be nice for me if I have these alerts, I have the sales data, if I have my forecast, if I have my stock levels, all of this in one central place, in one application, where I can look, do my analysis, use my best judgment, and make the intervention. This is just one such example, right? There are also a lot of time-critical examples. Let's say now it's 1 o'clock, I get the news that a fridge in one of the stores has broken down. At 2 o'clock is the order moment for the next day's delivery for this store. It's really time critical. I have to go, I have to check what can be done, and I have to stop ordering these items because I know that if they end up in the store the next day, they're not going to end up in the fridge, and that's going to lead to food wastage, and that's not what we want. So it's really essential that we have a system which is real-time with the most up-to-date information and is fast and responsive so that we can make these kinds of interventions on time. So you might be thinking, oh, that's quite easy, right? Getting all the data in one place. That doesn't sound like a lot. Probably all the big supply chains have some system like this. But in our case, we see that it's a really complex system to build. Just because we have enormous amounts of data. We have the 1 billion forecasts that Ruben generates every day. Plus, we have a lot of older forecasts. We have all the other information adding up to a total of 7 billion records that we have in a system. Our users, so the business users, need the flexibility to query this data at any level that they want. For example, they would like to look at an article across all the stores, or they would like to look at a store across all the articles. There are just these limitless combinations that can happen. So it's really impossible for us to pre-aggregate all of this data. And why it's even more harder to pre-aggregate something like this is because our data is also volatile. New sales come in, new forecasts are generated. So if we were to keep aggregating the data all the time, that would just be a waste of money, and it would not add a lot of value, right? And of course, as a business user or any user, you want your system to be fast and responsive. We have strict performance requirements that the screens have to load fast. Otherwise, people who use the screens every single day are going to get frustrated. So performance is really critical here. How did we go about building this kind of application? Of course, we didn't get it right in the first place. Let me walk you through our architecture very quickly. So on the left, we have all the forecasts and all the sales and different kind of data coming in to our data platform. There's a hammer over there that's a reference to Thor because that's the name of our data platform. Then via Azure Data Factory pipelines, we bring all the data into our Databricks environment, where we consolidate all this data. We join the forecast, the sales together, and we prepare this data for analysis for our business users. Then we load all of this data into a SQL server, and then we have an application, the demand forecast application, where the users can do their analysis, enter their adjustments, and that connects to our SQL server via stored procedures. There were two bottlenecks with this architecture. The first one being that we were transferring all this data from Databricks into the SQL server. You might be wondering, why do we do such a big transfer of data, right, if everything is in Databricks? But at the time, 3 years ago, or even before, there were some limitations that Databricks did not have the right capabilities, let's say, to do these kinds of high-performance queries, or they did have, actually, but that would mean we would have to run a compute 24 hours, and that would be very costly for us. So we decided to have this SQL server. But in the beginning, it worked really well. But as data grew, as we started onboarding more articles to this new forecasting system, we saw that this architecture didn't scale. And the second bottleneck, of course, was the most queries that we were running were analytics queries, right? OLAP kind of workloads. And the SQL Server was not, let's say, capable enough to handle these kinds of real-time dynamic aggregations on these billions of records. So we had to look at another solution. What was going wrong, of course, it was taking a lot of time for the screens to load. It was taking 10 to 12 seconds. There was a long waiting time for the data to be refreshed. So from the time Ruben generates the forecast until the time it's available for analysis to our users in the application, there was quite a while because we were transferring these massive amounts of data. And of course, the whole solution was expensive, right? You can imagine we have Databricks clusters running, we have a SQL Server running with the max number of cores, storage, and so it was overall a very expensive solution. And the worst of all, of course, we had these. We had our business users who were really frustrated, staring into our souls because the system wasn't fast enough. So how did we solve these challenges, right? It wasn't really easy. We did multiple proof of concepts with our partners like Databricks, Microsoft, and so on. We also looked with our internal data teams, developer teams, to see what kind of optimizations we can make. But we agreed that this was a very complex challenge to solve, considering the amount of data and also considering the latency requirements that we had. But luckily, with time, the technology also evolved. And with Databricks, there was a new SQL offering called Databricks SQL. And it was already there, but there it was a compute that you had to spin yourself. But luckily, they came up with a new feature called serverless warehouses, which is basically instant and elastic compute, so which is meant for these kinds of SQL workloads, heavy, OLAP-heavy workloads. And what SQL warehouses basically do is that they're a compute that starts within few seconds, right? It takes 2 or 3 seconds for the compute to start up. You run your queries. After a timeout, the compute shuts down. So you just pay for the queries that you run. So this was really good because it has a pay-as-you-go kind of model, which helped with our costs as well. So we stopped doing this data transfer to our SQL Server that was in the picture. You can see for reference in the down there. But you might be wondering why we still have a small SQL Server in this picture, right? Because, of course, we have a mix of OLAP and OLTP kind of workloads. Because, for example, when an adjustment is added or when master data needs to be retrieved, it needs to be in milliseconds. We have really low latency requirements for those. And, of course, Databricks, at least at this time, wasn't capable enough to handle these kinds of low latency. But I think something's coming there. But luckily, we could scale down our SQL Server because now we just needed to hold some adjustments and some master data, so there was not a lot. We scaled it down, and there is this good integration between these SQL warehouses and the SQL Server, so we can run all our queries on Databricks. What you might be wondering, what's this Kotlin Spring Boot application doing there, right? So previously, with the SQL Server, all our queries were written in Transact SQL. So that's a different dialect of SQL, whereas with Databricks SQL, you have to write ANSI SQL queries. So the dialects of SQL are not the same. So what this application in the middle does is it takes the inputs from the user. So for example, which item, which store, how many days of data, if it's in a particular holiday region or not, for example, translates these inputs into a query, into an ANSI SQL query that Databricks understands, sends it to the warehouse, and returns it back to the user. As simple as it is. And luckily, this also went with what our architects wanted. So it was a win for everyone. What did we achieve with this? You remember this person, the frustrated business user? Looks like this now. because the 10 to 12 seconds for him to load the screen, which was really terrible, now became 2 to 3 seconds. Of course, with the right architecture, we also had to do a lot of performance tweaks, improvements, all kinds of caching, and so on. But we managed to get really good results and what the business users wanted. With some queries, actually 60% of the queries, because there are a lot of repetitive queries running straight from the cache, so also within sub-seconds. So that's really good results considering it's billions of records that we are talking about on the fly. The long time for the data to be refreshed was now near real time because there was no data transfer involved, right? And of course, the cloud costs for this solution went down by 30% because we could eliminate the SQL server or actually size it down by more than 10-folds, and there was a great cost reduction for us. So it all worked out. In the end, we got very happy users. We got happy management, of course, because the cloud costs went down. And of course, happy developers because we had less operational overhead. And also, we got to work with the latest and best in the market. So that's quite cool. So wrapping it up together, over the past 3 years, we replaced our old forecasting solution with the new one. And since last summer, we're live with all the articles. While we keep listening and keep saying that AI will replace humans, we at Albert Heijn have seen that when AI combined with the right expertise from the human and the right tools and technologies forms the golden triangle to success. When all of them work together, that's when real impact follows. Just with this solution, in 2024, we reduced food waste by 1.3 million kilograms, contributing significantly to our milestone of 2030, and all of this, of course, while maintaining a healthy business. We've just started. The next big thing is that we're going to uncover the black box, the AI, and make it explainable, so that we have good insights. The AI explains and helps the business users understand why a forecast was made in the way it was. And this will help our business even more and help with better decisions that we make on the forecast and the adjustments. Thank you for your attention. Do visit our booth if you have any questions, and of course, our stores. Thank you.